everybody, and welcome to lesson 10. This is our final lesson. Unfortunately, some people have got sick children and work commitments, so we're a reduced number, but never mind, we'll have fun anyway. Any questions from last week? We looked at decimals and changing fractions, decimals, percentages. So we have basically covered the work in the Pebble Maths book. And the numeracy, early numeracy, which is add, subtract, multiply and divide, fractions, decimals, percentages. So we have covered it. So what I thought this week, we might do a few, if there's no questions from anybody or little areas that you want me to revise, we might just go over, add, subtract, multiply, divide. Oh, homework. You didn't remind me.
I was waiting.
Did anybody do their homework?
I had a stab at it. I'm not sure how successful I was. But
Right. Did
I was
anybody?
okay except for one. There was one digit I couldn't.
I think it was 7.
7,
Yeah,
yes,
right.
7, yes. How far did you
I
get?
don't know.
What about you? You didn't do it?
He did it mentally, like with discussion, but he didn't write it.
I wrote it down somewhere and I can't find it.
Never mind.
That was 7. I was one I couldn't do.
That's all right. But anything else you found?
Not all of them. And I had question marks around a couple of
All right. So we'll go through that first. So, good. All right. How do I tell if I can divide a number evenly by 2? It must be an even number. Now, Daniel, I'm going to pick you up on that because this is what people do. They say a one-word answer. You have to learn to give a sentence answer.
Yeah.
The number must be an even number, or in order for a number to be divisible evenly by 2, it must be an even number. Right? You're relating to what I'm saying?
Yeah.
Even though it's mathematics, I'm going to pick you up on that. I want really clear descriptions. Yeah? Okay, so should we go 2, 4, 8? No, we'll go down the list. How do I tell if I can? Yes.
I actually had it'll always end with an even number. Is that
Perfect.
the same?
Perfect. Why? That's the same thing, isn't it? Every even number ends in an even number. So that's just another way of saying exactly the same thing. Well done. It must end in even 2, even 4, even 6, even 8, or even 0. And then it's an even number. So that's an optional way of expressing the same thing. So how do I tell if I can divide a number evenly by 3, by odd 3?
If the digit sum is 36 or 9.
Perfect.
Is it always 3, 6 and 9?
Is it?
I had 12 and 15.
So tell me the digit sum of 12 and 15.
It's 5 and 6. Oh, okay. I can put note here, always add first and last number.
No, all the numbers. All right, let's look at digit sums.
I went in for the hundreds, so.
Yes, you add all the numbers. A digit sum is one digit, and there are 9 digits. 1, 2, 3, 4, 5, 6, 7, 8, 9. So if we're looking at 12, and we want the digit sum of 12, what do we have to do?
Add them together.
Add the digits together, and we get 3. So the digit sum of 12 is 3. What about the digit sum of 122?
That's 5.
That's 5. The digit sum is 5. Do you see it doesn't matter how many digits we have?
I think he's looking at, so if you put maybe 167.
167.
Seven and 1 is 8.
8 and 6.
13.
8 and 6, even and even. 8 and 6 is even and even.
Yeah.
Can we get 13 as the sum of an even and an even number?
You've lost me.
Okay. You were adding 8
Yeah.
and 6.
Yeah.
And you told me that's 13.
Okay, probably.
13 is an odd number.
Yeah.
And we're adding that, and that is an even.
Yeah.
And and that is an even.
Okay.
So if I'm adding
It
an
would be
even
number.
and an even, I must get a
The-
even number. What does even 8 need to make 10?
That's the part.
Okay, good. Let's look at that. Even 8 and even 6. Even 2, even 4, even 6, even 8. Even 2, even 4, even 6. If we're adding an 8 and a 6, the easy way is to make a 10, isn't it?
Yep.
So what does even 8 need to make a 10?
2.
Even 2. So even 8 and even 6 makes,
40.
yeah, are you seeing that now? Now have a look here and see if you can see it here. Not quite? Can you see your 8 here?
Yeah, I can see the 8.
Can you see the 6?
Yeah.
Can you see this there? Can you translate it to that, or it's not happening yet?
Oh, I see. Okay, so, right. Okay, but that's the part of the step that I forgot when I was trying to work
To make
it out.
the 10, okay? So the 8, so that makes up 14.
Yeah,
That's not the digit sum yet.
no.
So now we add the 4 and the 5, the 4 and the 1, and we get 5. The digit sum of this number is 5.
I was looking at pertaining to 3 though. Can we divide it by 3?
So can we divide this number evenly by 3?
No.
No, because it's got a digit sum of 5.
Yep.
How many remainders will it have?
2.
2. It'll have 2 remainders.
Yep.
So if I take the 2 off and I get 165, that number will be evenly divisible by 3.
Yep. Okay.
Because I took the 2 off.
Mm.
Let's check it out. 5 and 1, odd 5, odd 1 makes 6, and 6, 6 and 6 makes 12, 1 and 2 makes 3. Yes, that number's going to be divisible by 3. Okay? So that's a little bit extra on digit adding that I probably didn't make clear when we touched on digit adding before, that I can, if I get a 2-digit number when I add, then I add all the digits. Did I touch on throwing out the 9s? For example, 2, 3, 5, 6, 2, 1, 8. Now, instead of adding all those digits up, I can say that makes 9. I can say those 2 make 9, and 5 and 2 and 2 makes 9. So I've got a 9 and a 9 and a 9, and I know when I add a 9, I don't change the digit sum. So every time I've got a 9, I can throw it away. I can throw that away. I can throw that away, and I'll end up with 9 as the digit sum. I'll give one that's not a 9. I always seem to make 9s everywhere I go. I absolutely love the number 9. If I was asked what number am I, I'm a 9. Okay. Somebody give me a few digits.
7,
7.
3, 8, 5.
Keep going. Who said
6.
6? Daniel wanted to throw in a 4. Is that enough?
Yeah.
All right. Would you like to come and see if you can find some 9s? Am I putting too much pressure on
Oh,
you?
I love being put on the spot.
Okay. Can you find any 9s?
7, 8. Not easily.
Not easily. Can you find any 9s at all? A 6 and a 3. A 5 and a 4. Well done.
Okay.
And that's it. Well done. So Grant has found a 6 and a 3. They make odd 9, and a 5 and a 4 makes odd 9. So we can just leave those out and say 7 and 8 is 15. 1 and 5 is 6. The digit sum is 6. So,
What?
3.
pardon me?
So does that make that number divisible by 3?
And 6, because it's even, right? So, now I'll do it the long way. 7 and 3 is 10, and 8 is 18, and 5 is 23, and 6 is 29, and 4 is 33. 3 and 3 makes 6. I don't need to add all the numbers. I can throw out the 9s. If you look at your number 9 wheel, Grant has got a beautiful number 9 wheel. You and your wheels, you're famous for your wheels. Okay. Alright. I hope I don't put chalk on it.
No,
So, here we have 0. Every time we add a 9, can you see we're not changing the digit sum? The digit sum of every number here is 6. The digit sum of every number here is 5. The digit sum of every number here is 1. So when we add another 9, we've still got a digit sum of 1. Add another 9, we've still got a digit sum of 1. Do you see that, everybody? Does that make sense, Graham?
Yeah.
Right? So we can, it's called casting out the 9s. Every time we have a 9, we can let it go as far as creating, not adding the as far as getting the final digit sum, you cast out the 9s. So that makes life very easy, doesn't it, in getting the digit sum. And digit sums are really, really important, and they're not something you'll learn about in school, because they don't teach anything about digit sums as far as I know, unless we have a more enlightened teacher. So
The
yes,
answer to that one is 3. The head is 3, 6, 1, 9. I'm not, so when I was trying to do numbers, I came and thought it was 12 and 15. But okay, so it's 3, 6, and 9.
yes, can you see that?
Yeah.
If you look at in your multiply chart all along, your 3's up to 100.
Yeah. I'm not sure how I came to that one, but it was like.
Yes, you're doing well, Grant. If you look at your 3's up to 100 and add the digits in them all the way up to 100, and then keep adding the digits if you make more than 9.
Yeah.
Is it checking out?
Okay, so that's, let's say 84. That's 12. 1, 2, 3.
So the
Okay, there
digit
was
sum.
that one step I missed out.
I didn't explain it clearly. I rushed through it.
And I felt.
I did. I rushed through it. I didn't explain how adding again until you get the single digit. So I apologise for that. Is that clear for everybody now about digit adding?
Yeah.
And digit adding, I'm going to digress because it's our last class. Well, I always digress anyway, but I feel that this is the little bits and pieces class. Let's say I want to check an addition. Say I want to add 23 plus 12. What's the digit sum of this number?
5.
And what's the digit sum of this number?
0.
And if I add 5 plus 3, I will get 8. Now, let's see what I get. What's 23 plus 12? Sorry?
35.
35. And what's the digit sum of 35?
8.
8.
Oh, that's so cool.
Isn't that sweet? So you can check your addition by checking the digit sums.
Now, does that work always?
Of course.
So cool.
So you can use that as a check. That's called the digit sum check. Let's do a takeaway. Let's do 23 minus 12, because we've got all our digit sums there. So what's 23 minus 12?
That would be 11.
11. Is Grant the only person who knows 23 minus? Now do your digit sum checks there. Digit sum 5 minus digit sum 3 equals 2. Does that check out?
Yeah.
5 minus 3 is 2, isn't it?
Mm-hmm.
So you can use it for takeaway. Is that nice? You know how when you get these complex, when the children get quite a complex takeaway sum, I know it's when I was at school, when I checked something, if I'd already made a mistake, I'd make the same mistake again. Checking your work is often quite futile because you've got some sort of thing that you're doing that's not right. Often you'll just keep doing the thing that's not right. But if you've got a digit sum check, you go, oh, I've made a mistake. Now let's say I do 11 times 34. Can you give me the answer to that, please, everybody? How many? 374. Okay. Digit sum? 2 times digit sum equals 14. Digit sum? 5. Digit sum of this?
5.
5. So you can use it in multiplication. I lost your ground?
I'm just making how it
You're
works.
just amazed. So your homework will be Y, as always. But isn't that beautiful? I love digit sums.
Mm.
And this is only the beginning where we are now. If you choose to keep studying with me, we will go further and further into all these wonderful mathematical magic things. I'm trying to find a nice word for it. I don't know, I get overwhelmed. To me that is just so very pretty. So you can check your multiply. Do you like that? So with my old group who are doing things like 27 squared, in their head they can go, all right, 27, 2 and 7, 9, 9, it's got to have a digit sum of 9. Straight away. You don't have to think. The idea is that we don't have to do too much thinking, that all the patterns fall into place for us. Okay, so I've digressed, which I'm really happy about because we need to, pardon me, go a little bit further with. You like that, Grant?
Mm.
Yeah. You can see you can play forever with that. So, we've had a look at even 2, odd 3, even 4. How do I tell if I can divide, sorry, if I can divide a number evenly by 4? Half and half again. So when I halve it, I must get an even number when I halve it for it to be divisible by 4. We all got that? How do I tell if I can divide a number evenly by 5? Beautiful. What about a 6?
Struggle with this one.
You struggle with it? Okay, pull out your chart, pull out your multiply chart.
Well,
You
I
guys
got
have got
these with a 2, 4, 6 and then
Yeah, well, bring your chart over and you'll help explain it to everybody. Look at your 6s here. Who are your 6s? Let's create characters, personalities. What can you tell us about 6s in relationship to somebody?
that's half, double 3.
Yes, so you can relate it to the 3s, can't you? So when you're helping children, you don't just want fact, you want relationship. That makes everything easy. So relate it to the 3s now and describe what you see. Anything at all about the 6s and the 3s, how they relate. You can use your pebbles.
Well, they're all the same, you just miss one out.
They're all the same, you just miss one out. Good. So what he's saying, what Graham is saying, is that you've got this whole bunch of 3s and you miss one out, so that becomes a 6 and then that becomes a 6, right?
Yeah. Add 3s together, add 2 3s together.
Yes, so you're taking 2 3s to make a 6. Okay, where can we go from there, Grant, in discerning how do we tell?
I'd be guessing.
All right, can anybody help Grant?
2 3s make a 6.
2 3s make a 6, yes.
3 and 2, you would relate 6 to 3 and 2.
Sorry?
You would relate 6 to 3 and 2.
You'd relate 6s to the 2 3s, yes.
Yeah.
Good. So does that tell us anything about digit sums, Grant? Are all the 6s in the 3s?
Yes.
Yes. Every one of those 6s,
Is in the
yeah,
threes
also lives in the 3s.
And the 2.
So it must have a,
No. 3s.
yes. They all live in the 3s, don't they?
Yeah.
So what do you know about the numbers in the 3s? We've just talked about,
Yes,
we've
I
just
know,
talked
just
about the 3s. How do we look at the 3s? What do we look for in the 3s? When we're looking at a number to see if it's divisible evenly by 3, what are we looking for? If I say, is that number evenly divisible by 3? What are you looking for? Or how are you going to approach
Oh,
it?
yeah, when you're over
Right.
4 and 2, 6.
You're looking for the digit sum, aren't you?
That's the word, yeah.
You're looking for the digit sum. So what do you think here in the 6s?
Yeah, it's the same as 3s.
It's the same as 3s.
Hmm.
Right? So we're looking for the digit sum again, aren't we?
Yeah.
Check out the digit sums of your 6s, Grant.
Yeah, it has, yeah, I've actually written it down, it has a digit numbers, and I've crossed it out.
So you didn't believe it?
I didn't believe it, no.
All right.
Okay.
Did you look at your 6s and do the digit sums? Or you weren't sure how to do the digit sums at that point?
Yeah, I was actually looking at the last number because for me it was, it ended with a 2, 8, 4.
Which are what sort of numbers?
Which?
What colour are they?
Even.
Yeah, so it's got to be even.
Yeah, so it's always even.
Whereas in the 3s, what have you got? What's your pattern in the odd 3s?
Oh,
Odd,
even,
even, odd, even. So you're pulling out every second one, they're the even ones.
Mhm.
So, in order for a number to be divisible by 6, how would you express it, Daniel? Start from the beginning of the sentence. In order,
In order to divide a number by 6, it has to end, the digit sum has to be 3, 6 or 9, and it has to be an even number.
beautiful. See how nicely you did that? Now that was much better than saying even and digit sum. You know, we gave the whole story. That was really good.
Okay.
What did you think of Daniel's description?
Yeah,
Could you
that
relate
makes
to that?
Yep.
Did that explain it nicely? Excellent. So have we all got that? How to divide a number evenly by 6?
Mhm.
So can I divide this number evenly by 6?
Yes.
Yes. It's got a digit sum of 6 and it's an even number. So that is divisible by 6. Evenly divisible by 6. Now 7, everybody's saying, oh, 7's a bit tricky. So what we do with 7 is we turn it around. Do we all, I saw that question mark there, Daniel.
Get an L.
Turn it around, we get an L. That's very literal. Yes, if we turn 7 around, we get an L. Good. Not quite what I meant, but we're prepared for all eventualities. Okay, so did we look at, for example, if we have 8 times 7, 7 times 8, I've got 2 ways to go. I can look at 7 groups of 8. Let's have a look. 8 times 7. 1, 2, 3, 4, 5, 6, 7. 2 groups of 7. 3 groups of 7. Stop me if you don't understand, please. 3 groups of 7. 4 groups of 7. 5 groups of 7. 6 groups of 7. 7 groups of 7. Eight groups of 7. Can everybody see that I've got 1 group of 7, 2 groups of 7, 3 groups of 7, 4 groups of 7, 5 groups of 7, 6 groups of 7, 7 groups of 7, 8 groups of 7. That's if I look at it this way. What about if I look at it this way?
7 groups of 8.
I have 7 groups of 8. So I can do my multiply either way. 7 groups of 8 or 8 groups of 7. We're all clear on that?
Mm-hmm.
And to answer Jacqueline's question, because she's going to say, is that the same for every number? Yes, it is. Yes, it is. 3 times 4 is 4 times 3. If you don't, not sure, you build 4 groups of 3, and you look at it from the other way, is that 3 groups of 4? And you do it until you are getting the patterning. So, I can choose to multiply by 7 or multiply by 8 for this one. Multiplying by 8 is easier, because I know how to do that. 8 groups, even 2, even 4, even 6, even 8. 8 groups of what, Grant? 8 groups of what?
7.
8 groups of 7. Where do I start? Where do I start if I'm multiplying by 8? 2, I start with my 2 groups. Mirror game. 2 lots of 7 is, what have we got here?
Oh, 5. Sorry.
Okay, you've
I
got
forgot.
7. No, don't even try and remember.
Okay.
You've got odd 7, I've got odd 7.
Yeah.
Double 7, what have we got here?
Double 5.
Which is
10.
10 and
Double 2, 4.
10 and a 4. Double 7 is a 10 and a 4. You've seen that? You need to practice your mirror game.
Yeah.
So you can do double anything. Double 6.
Double 5.
So just say what that is. 10,
10 and 2.
10 and 2. Double 8.
10 and 6.
Perfect. Right? Practice your mirror game. Everybody else is okay with that? Good. So 2 lots of 7 is a 10 and a 4. So how do I do 4 lots of 7? Double that, and I'll get 28. So to get 8 lots, double 28, 56. Right? So here are 56. So I can do, so if I've got 7 times something, I can swing it round the other way. 7 times 5, 5 times 7 is 7 lots of 5. 2 lots of 5, 4 lots of 5, 6 lots of 5, can you give us your 5s? 6 lots of 5 and a 7 lots of 5. How many lots of 5 have we got now? That's it. So 7 lots of 5 is 1 10, 2 10s, 3 10s and a 5, isn't it? Sorry Daniel, I left you out. Do you see that? So there's only one that we have to actually know. What would that one be? 7 times 7. 7 lots of 7. Which I'm going to tell you is 4 10s and a 9. And that's the only one we really have to keep in our head. But we can always work it out. It lies between 8 7s and 6 7s. Right? So if we know 8 7s, we can take off 7. If we know 6 7s, we can add a 7. Because 7 lots of 7 is 1 more 7 than 6 lots of 7. Have I got you confused?
No?
Yeah?
I'm there.
You just draw your bags and you see it. So that's how I do my 7s. And I once spent some time playing with the number patterns in the 7s. You did too, didn't you? I think we spent forever playing with number patterns. And we found some very interesting patterns, but I'm not going to tell you what they are. I'm going to let you play with that yourself. So you just write out your 7s on a new sheet of paper. 1 lot of 7, 2 lots of 7, write them along, get the answers, and then play. And you're looking for end numbers, digit sums, whatever you like. And find your own patterns, and then you'll connect with it.
Yeah, I really.
You didn't like the
I
7s?
couldn't see anything in there.
Can I make
Okay,
that?
that's all right.
Can I tell you, I showed us something once, and how you could add 10 to 7 and take away 3. And I found that easy to do the 7 times tables.
Right. Yes, Jacqueline, we were looking at the fact that odd 9 is a 10 minus 1. Even 8 is a 10 minus 2. So if you're adding 8s, which is all that multiplying by 8 means, you're adding a 10 and taking away a 2. So if you're multiplying by 7, you're adding a 10 and taking away a 3. Right? So there's a little game I used to play in class where so for example, we were adding 9s. So somebody would think of a number. Daniel, a number. A 1-digit number. 6. And then the next person has to add 9. So you add a 10, take away 1, and you get
15.
15. And then add 9, 24, add 9, add a 10, take away 1.
33.
Perfect. And you keep going, adding 9s until you've had enough, and then you take away 9s. So then you try 8s. Jacqueline, can you give me a digit?
7.
7. Then we add 8. Add 10, take away 2.
16.
Okay, 7. We're adding 8.
Oh,
What's 8? 8 is adding a 10 and taking away 2.
And it would be 15.
And it would be 15. Add 8. Add a 10, take away 2. 23. Add 8. Add a 10, take away 2.
So is it 23? 31.
Perfect. And then you do your 7s. Add a 10, take away 3. And that's a really nice game around the class, and it also shows the teacher who's got it and who hasn't, who needs help. Right, so that's a really good one to do. You do it in the car with children. That's a good one to do in the car. I like that one. So while we're looking at multiply, we'll look at divide. What have I got here? I've got 8 lots of 7 or 7 lots of 8. If I share this or divide it between 7 people, can you put the 7 people where they're going to stand so they can see what they get? The 7 people. Where are they going to stand? They're sharing this.
Oh,
So where are they going to stand? Perfect. They're going to stand on the side where we've got the 7. Perfect. And how many are they going to get each? 8. And if we shared with 8 people, they would move around the side. And how many would they get each? They would get 7. And these are called number facts at school. 7 lots of 8 is the same thing as 8 lots of 7. And that number in there, whatever it is, divided by 7 will be 8 each, and divided by 8 will be 7 each. Are we seeing that, everybody?
Mm-hmm. Yeah.
Beautiful. Lovely. So we've done 2, 3, 4, 5, 6, 7, 8. How do we tell if we can divide a number evenly by 8? How do we tell it? So again, go to our pizza.
Half and half again.
Half, half and half again. Yes. So it's getting hot, isn't it? Middle of winter. So I always go back to my pizza. I want to cut it into 8. I've got to be able to cut it in half. I've got to be able to cut it in half again and get what sort of a number?
Even.
I've got to get an even number when I cut it in half twice.
Yep.
We all right with that? How do I tell if I can divide a number evenly by 9?
Digit sum of 9.
Digit sum of 9. Look on your 9 wheel. All the ones that are in the 9 with no remainder have all got a digit sum of 9. How do I tell if I can divide a number evenly by 10?
If it ends in a 0.
If it ends in a 0, how can I tell if I can divide a number evenly by 11?
If the middle number adds up to the outside.
Right, so if I have 1, 4, 3, can I divide that number evenly by 11? Yes, because 1 and 3 makes 4. How many lots of 11 is that?
4.
How many lots of 11 is 13? 11 times 13 is 1, 4, 3.
Now how does that rule work if you have a 4-digit number?
Let's stay with this. We'll stay with this.
Sorry.
See me after class.
I love the wallies.
She's always pushing, which is great. It's great. When the children are doing that, it's beautiful. Sorry, Grant?
Oh, yeah, I struggled with the level because I couldn't work it out, but I was going into 4-digit numbers as well, and that's what I probably got 3.
We have to be solid here
I know how to do
first.
it because I've worked it
Yeah.
out, but it doesn't, the rule doesn't necessarily agree.
Or the pattern. Let's
Yeah.
call it a pattern rather than a rule. So what you do is pull it apart, multiply by 10, add 1, change it around, see what you come up with. But there are definitely beautiful patterns for multiplying and dividing by 11.
And it's still really easy when you understand how, whether you've got 4 or 5 or 6 digits, it's like,
Yeah.
oh, cool.
Yeah, it's a lot of fun. Okay, so we're up to 12. How do we tell if we can divide a number evenly by 12?
If it's digits divisible by 6 and 2.
If it's divisible by 6 and 2. So what Amber has brought up is what we touched on last week. It's got to be divisible by 6, which means it's got to have a digit sum of 3, 6 or 9.
And
It's got to be an even number.
An even number.
It's got to be divisible by 4 then, hasn't it? If we halve it, it's still got to fit the rule. So, give me a number in the 12s,
36.
a bigger one. Give me a number in the 12s. In the
96.
12s. Is 96 in the 12s? Okay, 96. What's its digit sum?
6.
Its digit sum is 6.
15.
No, we don't. We can throw out the 9.
Oh, of course.
We can throw
6,
out the
which is-
9, it'll be 6, and it's an even number, so we're looking good. Now let's halve it, and we will get
3. Are we even, sorry, what are we having now?
96. We're halving the 96, and we will get 48. And let's halve that again.
20.
Oh, look, we can divide that by anything. So that's definitely divisible by 12. Do you see what I'm
No, once
saying?
upon a time I would have looked at 96 and thought you couldn't have it.
You couldn't halve it because the first number's an odd.
Yeah.
Yeah,
How many people think
That's-
that?
yeah, I was
You
thinking
can't
that
halve
was going
9.
Do we remember? Do we know how to do it?
Yeah.
Grant, shall I go over that?
I've forgotten, I'm sorry.
All right. No, we're not trying to remember anything. We don't like the odd number of tens.
Oh, that's right, so we
Right.
make it a-
What do we do with an odd number if we want to make it into an even number?
You
Look at my odd number. What am I going to do to that to make it into an even number? What are you going to do to it?
take one away.
Take 1 away. That's all you've got to do.
Yeah.
Take a 10 away, you can't throw it out.
Yeah.
So what are you going to do with it?
You add it to the next number.
Yes, which is what column? What are they, the next number?
I'm sorry, I don't know.
All right. These are called tens. What are these called?
Ones.
Ones. Perfect.
So you're adding it to the 1.
Exactly, to the ones.
Okay, I forgot that you can go backwards on that.
You can go all over the place. If I take away a 10, I can give it over to the ones. Let's have a look at it. Let's divide 32. 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. Can you see 3 tens and a 2?
Yes.
Can everybody see 3 tens and a 2? What don't I like?
The 3 10.
I I don't like an odd number of tens, do I? You with me, Graham?
Mm-hmm.
I don't like an odd number of tens. What do I do to my odd number of tens to make it into a nice even number?
Take one away.
Take one away. What am I going to do with it?
Put it in the ones.
Put it into the ones. I've transformed my 3 tens and a 2 to 2 tens and a 12.
Mm-hmm.
Can I divide this by 2?
Yes.
And we'll get
10.
1 10 each. And divide this by 2,
Yeah, you get 6.
and we'll get 6. 16 is the answer. Okay, back to that one. 9 tens and a 6. What are you going to do with that?
Take one off the 9 and
Mm-hmm.
add it to the 6.
Mm-hmm.
So you're halving 9, 4, but how you can't halve 7.
Is that 7?
6.
If I take a 10 from the 9 tens,
When you say add it to the 6, you don't mean literally add it to the 6.
yes. Let's say I had 9 tens here and a 6, right? Can you imagine 9 tens along here?
Yep.
I don't like 9 tens. What am I going to do
Take
with
one
my...
10 away.
I'm going to take 1 10 away, and what am I going to do with it?
Oh, and then you halve it because it's 10. Okay, I got it.
And then I'm left with 8 tens and a 16.
Okay, yeah.
Half of 8 tens is 4 tens, and half of 16 is the mirror game in
Is 8.
reverse, is 8. Half of that, we've made 16, I'm going to take my half. Half of 16 is
Right.
even 8. You got it
I
now?
haven't added the other 10.
Right, you need lots and lots of pebbles and you need to play. It's all play.
Okay.
All clear? Right, so we can tell, we've got our multiply tests now, haven't we? Now, Amber, you touched on, how do we tell if we can divide a number, for example, by 15? How do we tell if we can divide a number by 15? Let's look at our 15. Pardon?
Divisible by 5 and 3.
Yes. Look at 15. Amber's saying 15 is 5 times 3, or 3 times 5. Can you see that? 3 lots of 5. Can I have another 5? 3 lots of 5 is 15. So it's got to be divisible by 5 and 3. So you can play around with lots and lots of different...
So then it has the same rule as well as the 5? Like it would have to end in a 0 or a 5?
And it would have to have, in order to be divisible by 3,
Digit sum of 3, 6 and 9.
yeah, it would have to have a digit sum of 3, 6 or 9, and it would have to end in a 5 or a 0. So can you make up a number that could be divisible by 15, say a 3-digit number?
$120?
120, perfect. 120 is divisible by 15, because it ends in a 0, and it's got a digit sum of 3. It's cool?
Yeah.
We're cool. This is the cool school. But that's nice, isn't it? It's powerful. All right. Any questions on that? So how do we feel now with our add, subtract, multiply and divide? Do we feel confident? Or do we feel that we're getting there?
I need a lot more practice.
Everybody needs practice. Grant, we've done a few hours together. We can't go from, I haven't been able to do maths all my life, to I'm Einstein with just a few hours of tuition. We need, why not?
I'm certainly much closer to being nice.
Much closer. We need to practice, you know. This is, for example, when I have children who say are in year 8 or year 9 or year 10 and they've got no maths, and I show them, oh, now I get it, now I get it. I say, well, everybody else has had, 6 years of practicing that. So You don't need 6 years, but you need to do a bit of practice to get it really solid.
Mm.
But do you feel you've got the tools?
Definitely got tools. Yeah.
Great. All right. Any other parts that we feel we'd like to revise? Daniel, what about you?
Not really.
You're all right with everything?
Yeah.
Jacqueline,
I think I'm good. Yeah.
Yeah.
you're okay? Grant, anything in particular you'd like me to revise? Take away?
I can't pinpoint anything in particular at the moment.
Okay. All right.
I'm sure it's...
Yes.
The digit sum check, it wouldn't work with dividing numbers, or
Is that a question? Is that a question? Or is that a statement? Are you telling me it won't work with dividing numbers, or are you
I
asking?
wouldn't think so.
You wouldn't think so? All right. How would we work that out?
Question.
I think it's a question. So how would we test it?
By thinking of a sum and
All right, let's say 42 divided by 3, yeah, equals 14. Right? Yes? Digit sum 6, digit sum 3, digit sum 5. We've gone the other way around the wheel, I'll bet you. Have we or haven't we? No. There's something I've missed here. Good question, Amber. Let's look at the, why hasn't that worked? Because 6 divided by 3 should be 2, shouldn't it? How can I relate that to 2? I shall have to work on that. I'm missing something. What am I missing? Let's try another one. Give me another one. We won't do 81 divided by 9, that's too simplistic. 144 divided by 12. Oh no, again, we won't work with 9s. Give me a number in the 12s. 96 again? No, we won't do 96. Yeah, we can do 96. All right, 96 divided by... No, we've got the same numbers again. You'll have to leave that with me. You've given me homework. I know there is a
so it's all
difference.
sitting here on the edge of our seats.
Well, rather than leaving me with the homework, why don't we all do the homework? How do we see if the digit sum check works for divide? Because Anne's obviously been thinking about it and thinking things like this and thinking, no, it doesn't work. But it must work. There's something we're missing. So homework is exploring digit sum checks in... Yes? Yes?
I'm wondering if you multiply the 5 by the 3, which gives you 15, which
Ha.
gives you a digit sum of 6.
Ha! Ha!
I got chills.
5 times 3 is 15, digit sum 6. I think a big round of applause for Jacqueline.
I got chills through my whole body when I saw that.
How exciting is that? How exciting is that?
Now the question is, does it work with every number?
Okay, give me some more numbers. It wasn't very long ago that Jacqueline was struggling with addition. Is that right?
Oh, no, very much.
And look what your mind is now extending to. That's beautiful, Jacqueline. Why did Jacqueline multiply that by that?
Oh, 'cause that gives the answer.
That gives the answer, doesn't it? If I multiply that by that, that's that. If I say 6 divided by 2 equals 3, 3 times 2 equals 6. So Jacqueline worked it back the other way with the digit sums. All right, great. Jacqueline, take over. So let's have another one. You can look at your multiply chart and give us some numbers. Say something in the sevens, something nasty.
49
49
divided by 7. Is that
divided by 7
So it's 4.
equals 7, right? 7 times 7
Is 49.
is 49.
We're
Wait a
doing
minute.
digits.
Digit sum. Maybe we need to use, I
So
mean,
4.
Yeah, and then they,
they're both 4.
which is
Oh wait, this is 4.
But give us a bigger number. A bigger number to divide by.
only 6.
Well, do
And
something
seven.
divisible by 15, for example.
84.
192 divided by what?
7.
7 equals
Um,
26.
yeah.
Is that right? Is that right? No, it isn't.
Is it 28? Wait, I don't think it could.
It's not. That's not a multiple of 7. So what are you doing to me? That's not a multiple of 7.
Just checking if you.
Just checking if I got it. All right, give me a nice multiple of 7. 154
Yeah.
divided by 7 is 22. Yes? Right? So what do we do now? We say digit sum 4. 4 sevens are 28. Is that digit, which will be 1, won't it?
Yeah.
Digit sum 1. Don't worry, Grant.
We
Which
throw
is-
the 9 away and you're just using digits.
Yes, we throw that away. That's a 9 and that's a 1. I say, no worry, he's onto it. So you're right, Jacqueline. You're absolutely, absolutely right. So now you can play with that. And you can check if your division is correct. But what was that multiple of 15 that you gave us? A number that's a multiple of 15. Was it 120?
Yeah.
All right, 120 divided by 15 is
8.
8. 2 15s, let's check. 2 15s are 30, so 4 15s are
60.
60, so 8 15s are 120. 2, 4, 8?
Yeah.
Yeah. So what did we say it is?
8.
That's 6, isn't it? 6 8s are 48, digit sum 3, digit sum 3. Have to play with it. But congratulations to Jacqueline for seeing what we do, seeing the method. And the only reason Jacqueline saw the method, because she's never learnt this before, is from her own understanding of how it works, which is lovely. When we start discovering for ourselves, that's beautiful. That's what we want.
And that only came out of the learning the relationship between adding and subtracting, multiplying and dividing, by understanding like how you've taught us how they relate to one another.
That's right. And by having faith that if the digit sum check works for add and subtract and divide, that it must work for divide. It must work for divide. And if we know it must work for divide, we keep looking. If we have faith that it must work, we keep looking till we find it. I mean, at the moment, Ken sent me somebody or another's conjecture on prime numbers, and this patterning was, anyway, it was on prime numbers, but of course not odds and evens, and not the way that I look at numbers. So I thought, well, I'm going to do a Vera's conjecture here on prime numbers, and I wrote out all the prime numbers to 100, and below the line I did differences and odds and evens, and above the line I did digit sums and digit sum differences, and I went a whole page and couldn't find anything, couldn't find any patterning at all, and I said, Amber, you do it. She said, what you could find. because I do believe in my heart of hearts there must be a pattern there based on odds and evens. Because that's what I believe so much in my heart. So I won't let it go until I've exhausted myself in finding out the patterning in the primes. And that's the joy of when we're looking at maths in a creative way. That it's not just about doing the sums that we get at school or at university or in life, but actually having that desire to see how the numbers work, and that desire to find out things that haven't been found out before. And that's the exciting thing. So if there are no questions, I'm going to leave it here with the hope that we now feel inspired.